Hi Lungile again. So now we're gonna be carrying on, okay, with the topics in maths. Okay, so we're gonna be doing prime numbers this time, prime factorization, as well as highest common factor. Okay, so this is what you're gonna do. Okay, now we're gonna discuss the concepts and do some examples so that you understand. Okay, so it's very important that after you you have actually gone through the whole video, okay, and you can just give yourself some practice to the same examples, okay, by yourself, okay, to see that if you really understood, okay, the concept. What matters is the understanding. Feel free to pause the video whenever so that you grab it, okay, you grab it and understand it fully. Okay, so this is what we have: prime numbers. Okay, prime numbers are numbers that has exactly two factors. Okay, they have exactly two factors. Okay, so it's usually one, it's always one and itself. So a number that has a factor, okay, that is one and itself, that is considered a prime number. Okay, so what are factors? What are factors? So a factor is a number that you can be able to divide it, okay, to the original number. For example, let's say I have 6. This is my original number. 2 is a factor of 6. Okay, why am I saying that? 2 is a factor of 6. 2 is a factor of 6. So what does it mean? It means that if I say 6 divided by, oh sorry, sometimes this thing goes slowly and goes messy, the pen. Okay, so 6 divided by 2 is 3. Okay, so 6 divided by 2 is 3. So that's what makes it to be a factor of 6. Okay, because when you divide it to the whole number, it gives you another whole number. Okay, so factors are numbers, okay, that when you divide, okay, to this original number, you get another whole number. Okay, you don't get numbers that are decimals. For example, if I say 6 divided by, let's say, divided by 4, let's see if 4 is the factor. Okay, let's see if 4 is a factor. So if you punch in 6 divided by 4, you get an answer of 1.5. Okay, 1.5. Is this a whole number? No, it's a decimal. That means 4, it means 4 is not a factor of 6. Okay, it's not a factor of 6. Okay, 4 is not a factor of 6. So now let's say we pick 3. Okay, so if we say 6 divided by 3, we get 2. Okay, we get another whole number. Okay, you see that we get another whole number. This means that therefore 3 is a factor of 6. 3 is a factor of 6. Okay, so I want you to first understand what are factors necessary. Okay, factors are numbers that to the original number, okay, they give you another whole number. So if any number that is giving you a decimal when you divide it to the whole, to this original number, and it gives a decimal, it's not a factor. Okay, remember also factors they cannot be bigger than the number. Okay, so if I want factors of 8, they will all be below 8. Okay, why? Because factors they can only be below. Why? It's because factors are numbers that get in, or that can divide, that gets to a number. Okay, that can divide a number. Okay, so I think you understand now what are factors, and it's something that you have covered, I think, from earlier. Okay, so factors are that. So now prime numbers are numbers that has factors that is only one and itself. Okay, any number can divide itself. Okay, for example, 6 is a factor of 6. Sorry, 6 is a factor of 6, because when you divide 6 by 6 you get 1. 7, its factor is also 7. Okay, because I don't know what's going on with this, they give me errors. So 7 divided by 7 is 1. Any in any number, one factor that it has, it's itself. Okay, because when you divide by itself it gives you 1. So now prime numbers are numbers that have only 2 factors. They don't have any other factors. Okay, they don't have any other factors. They don't have any other factors. They only have 2 factors, which is 1 and itself. 1 is a factor of every number that exists in this world. Okay, because any number divided by 1, it becomes itself. Okay, so I think now you get the idea. So these are the examples of the prime numbers. It's 2. Okay, why? Because 2 has only 2 factors, 1 and 2. 3 has only 2 factors, it's 1 and 3. Okay, you can't say 2 is a factor of, because when you divide it, it's gonna give you a number with a comma. Okay, 5 also has 1 and 5 as a factor. Okay, so this type of number, 7, 11, 13, I think also you go to 17. Okay, carrying on like that. Okay, 23, all those things. Okay, so those numbers, they are numbers that are prime numbers. Why? Because they only have 2 factors. There's no any other number. So if you are given a number like 8, it has factors 1, 2, 4 and 8. Okay, so it has 1 and 8. Okay, every number can have 1 and itself as a factor, but this one has 2 additional factors. 2 can get into 8. Okay, and it will give you 4. That means 2 is a factor of 8. Okay, even 4 is a factor of 8. So since this one has more than 2 factors, it cannot be a prime number. Okay, so it's not a prime number. This one, 8 is not a prime number. So I think you get the idea now of what are prime numbers. Prime numbers, they only have 2 factors. It's itself. Okay, so that's it, keep it in mind. Okay, so let's go to some examples discussing about the prime numbers. So the first example is saying 17 a prime number. Okay, you can first check. Okay, that is, do you have any number below 17 that can divide completely 17? Okay, and if you keep on checking 2, 3, 4, 5, 6, 7, 8, all those numbers, you'll find that there's no number that can divide 17. Okay, and give you a whole number. Okay, so that means 17 is a prime factor because it only have 1 and 17 as a factor. Okay, find all prime numbers between 10 and 30. Okay, so the prime numbers between 10 and 30 is 11, 13, 17, 19, 23, 29. Okay, those are the prime numbers between 10 and 30. So which means all of these numbers, they have only have two factors. It's 1 and itself. Okay, they don't have any other factors. You can please confirm all of that, okay, to all of these numbers. Confirm it to see. So this is how you can answer this question. It's 11, 13, 17, 19, 23, and 29. Then, so these are the prime numbers. So it's very, very important to understand the prime numbers, okay, so that you have an idea, okay, when you get something called prime factorization. So let's go with the examples and proceed. So which is the smallest prime number? Okay, so the smallest prime number of all time in this world, okay, is 2. Why? Go back to the list here. You see, I started with 2, 3, 5, 7, 11, 13, all of that going forward. These are the prime numbers. So the smallest prime number of in every time is 2. Okay, 1 cannot be a prime number, okay, because 1 has only one factor, which is 1, so it cannot be a prime number. So the first smallest prime number is 2. Okay, I hope this is understood. Okay, true or false? Okay, 1 is a prime number. False, it only have one factor, so it cannot be a prime number. So this is correct, it's a false. Okay, it's a false answer. 1 cannot be a prime number. Okay, let's go. Then we have which is the next prime number from 31? Okay, so we're gonna think of numbers from 31 going forward. 31, 32, 83, sorry, we have 30, 34, 35, 36, okay, 37, 38. Oh, what am I writing? Okay, 38, on and on going forward. Okay, so we want to find which is the next prime number, okay, from 31. Okay, so if we keep on checking that, okay, you're gonna see that 32 cannot be a prime number because it has more than one prime factors. 33, it has factors like 1, 3, 11, and 33. And 33. So it cannot be a prime number. 34, it has more than one. 35, it has more than one. 36, so it's only 37. You can check it. Okay, so 37 is the prime number after 31. Okay, because 37 has only two numbers. Okay, 37 is only two numbers. Has only two numbers. I hope that is clear. 37 is only two numbers. So is 91, is 91 a prime number? Okay, no, it is not. Why? Because 91 has has factors like 1, 7, 13, and itself 31. So this is not a prime. Okay, because it has more than 2. Okay, or it has other prime, it has other factors that are not 1 in itself. Okay, so as you can see here, it says no because it has the answer like 7 and 13. Okay, so this is how you work out these problems. Okay, so there's now a one trick that you can see also how to find a number is a prime number or not. Okay, so let me tell you this trick. So if you go to your calculator, okay, let's just check if 73 is a prime number. Okay, go to your calculator, you go press 73, okay, then press equal sign. Okay, after pressing the equal sign, press shift, okay, then press the button that has factorized, that has this name, okay, this weight, okay, fat. Then when you press shift and press that button, you'll find out that, and then you press equals to, okay, you find out that it gives you nothing. Okay, it gives you nothing. So you can see that now, since you just did that and you found nothing, that means this is a prime number. Oh, sorry, this is a prime number. So you can please forgive me with the network, it goes slow. So this is a prime number. Okay, so let's check another number. Let's check which one, 71. Let's see if it is a prime number or not. Okay, so if you press 71 in the calculator, press equals to, shift, press the button with effect, wait, that is a factorized, right? When you press that, you see that you get 71 again. Okay, you get a 71 again, you get a 71 again. So 71 is not a prime number. I mean is a prime number because you get itself again. So whenever you press that button of factorize, then you get a number again itself. It means that number is a prime number. Okay, so let's check another one, 56. Let's check 56. Oh, okay. Oh, I wrote 53. Let's just go to 53. 53, press equals to, okay, and press shift, factorize. 53, when you press 53, it gives again itself when you press in your calculator. After pressing the button that says factorize, you see you get again the same number, nothing changes. Okay, so that means this is a prime number because it has only one factor seen there, which is itself. Okay, in a calculator. So I don't know what this is for. It's a prime number. Okay, I don't have to write that. Then let's check 56 that I was talking about. Okay, let's check 56. So 56, punch 56 equals to shift the fact button. Okay, you get an answer of 2 to the power of 3 times 7. Since here in this part you get these numbers as the factors, okay, or the factors of 56, you didn't get 56 back itself. It means this is not a prime number. Okay, not a prime number. I meant to write not here. Okay, so I'll give you a prime number. Okay, we can keep on making many more examples, but this is another way of how to find if a number is a prime number or not. Okay, for example, let's go for, let's say 36. Let's see if 36 is a prime number. You go to your calculator, you press 36 equals to shift that fat button, and you get something that is like 2 to the power of 2 times 3 to the power of 2. Since you get more than two numbers, okay, I mean since you get more than two numbers, why I say that, 2 squared, there are two times, there are two twos, okay, which means there's even more of the factors, okay, and that means this is not a prime number, okay. Once you get something that is like this, okay, this is not a prime number, not a prime. Sometimes this thing goes off, I don't know, okay, it's not a prime number. Then let's let's say 17, for example. 17, if you press 17 and press equal to shift fact, if you get that, you punch this in the calculator, it gives you back again 17 in the calculator. Check that. That means this is a prime number, where every time when you press that factorize bracket, and it gives you back the same thing, this means that number is a prime, okay, is a prime number, okay. So let's check the last one before we shift forward, okay. So let's check the first one, the last one. So let's check number, like which one? 23. Okay, let's check 23. Let's check 23. So if you write 23, where is it? 23. Okay, go check it in your calculator. Just say 23 equals to shift factorize. You get back 23. Okay, I hope you have done that in your calculator, and this means this is actually a prime number. So every time when you try to fix the factorize by the calculator and you get the number back, it doesn't simplify, okay, like this, it means that number is a prime number. But if you try to press the calculator and the number simplifies to this factors, okay, this means this is not a prime number, okay. I hope you grab that. Keep on practicing further and more. You can just also go back to the previous examples we made here, okay, we made here, and see if you understand really, okay, why these are prime numbers, okay? And keep on checking everything, okay. So I think now we can move to what's so-called factorization, okay. So prime factorization is expressing a number as a product of prime numbers, okay, expressing a number as a product of prime factors, okay. So normally we do this, some people, they do the prime factorization in a ladder method, okay, using a ladder method, okay. I think you're familiar with that, okay. Let's pick a number like 36, okay. You usually say 36, right? 36 here, right? And you'll say which number that divides, which prime number that can divide 36. Then you say, okay, let's say 2. Pick 2, and you're gonna say 36 divided by 2, you get 18. Then you say which another number that can divide, another prime number that can divide 18. And you say, okay, let's say 2 again. 2 divided by 18 is 9. And you say which other number that can prime number that can divide 9. It's 3. Okay, 9 divided by 3, it's gonna give you 3. Which prime number can divide 3? It's 3 itself. 3 divided by 3 is 1. So whenever you reach 1, you stop, okay. So that is how you've been doing prime factorization, and this is gonna tell you that all of these numbers except 1, okay, are prime factorization, which means 36, okay, is equals to 2 times 2 times 3 times 3. Okay, you just took the same numbers that you have here. Then you're gonna say 2 times 2 is the same as 2 squared. You know that, right? Because this has power 1 and 1. Okay, so when you multiply this, you add the exponent. Okay, 2 is like 2 times 2 is 2 squared. 3 times 3 is 3 squared. So this is the prime factorization. Okay, using the ladder. Okay, however, as sometimes you don't have to do a ladder method. You can just use a calculator. Okay, same thing at the science. Go press 36 in your calculator, press equal sign, shift, factorize in that that has that is written like this. Okay, this button is for prime factorization. So when you press that, you're gonna get something that is like this. Okay, something that is like that. So that is how you get to solve these things. Okay, then you can go and check also for 48. Okay, so instead of doing the ladder method that is long, sometimes you can go to your calculator, press 48 equal sign, shift, fet, then you're gonna factorize button, then you're gonna get this. Okay, so this is prime factorization. I think it's easy to do it. Okay, same thing, go press 100 in your calculator, you're gonna see it's gonna simplify it to this. Check these things. Okay, go press 30. If you go press 30 in your calculator, simplify, it's gonna give you this. Okay, and try to do a prime factorization. Okay, gonna give you this. Okay, and if you go try to press another one, which is 45, it's gonna give you 3 squared times 5. Okay, so yeah, we haven't talked about the highest common factors. They're still gonna discuss that. So these are prime factorizations. Okay, so prime factors of 72. Again, if you want to get prime factors, this is what you do. You go press your calculator, this are the prime factors. Okay, 2 and 3 are the prime factors. Prime factors of 72, go press the calculator and you're gonna get the correct answer. Okay, we don't talk about the lowest common multiple yet, so but what is the main of this lesson, Lungile? Understand how to get prime factorization, how to factorize, how to get prime factors. So when you do that in your calculator, it's gonna give you exactly the prime factors. Why we say this is our prime factors? Because we know 2 is a prime factor and 3 is a prime factor. So for example, get prime factors of 8. Okay. You go to the calculator, press equal sign, shift, factorize, you're gonna get 2 cubed. Okay, this means a number that is here, not exponent, is a prime factor. So 2 is a prime factor, 8. Here for 48, what are the prime factors of 48? Is 2 and 3. Okay, and the prime factorization is 2 to the power 4 times 3. Okay, hope you get that. Keep that in mind. So before we end the video, let's go to the last part of the video. Last part of the video. So the last part of the video is dealing with highest common multiple. Highest common multiple. So please pay attention. Please pay attention. Okay, so the highest common multiple is the largest number that divides exactly into 2 or more numbers. Okay, so highest common factor, okay, is a number that is the largest number to divide, okay, that number. Okay, or those 2 numbers or those 3 numbers. Okay, depends. So When you get the highest common factor, you're gonna be given sometimes two numbers, and they will ask you, okay, total highest common factor. Or the moment the numbers are 3 and they say total highest common factor. Okay, so there's a way of getting highest common factor. To get the highest common factor, you must know first the the prime factorization. Okay, but lana kule part ku number 1 ngenze ngenye indlela. Uyabo ukuthi ngenze njani? Ngiyithole ngama factors. If you check, the factors of 12 is 1, 2, 3, 4, 6, 12. The factors of 8 is 1, 2, 3, 6, 9, 18. Okay, so the highest common factor is the largest number that divides exactly the two into two numbers. Okay, so what is the largest number that divides both 12 and 18 here? Largest. You can see that in these factors we have 6 as largest factor, which is dividing both numbers. So that's why we say largest number that divides exactly two numbers. Okay, and that is 6. This is the largest number. So that's why we say one factor here is 6. Okay, is 6. Now let's see how can we also work this out differently from this now. So let's use another method that you are familiar with it. Okay, the other way to solve this problem, you can say 12 and 18. Go to your calculator. Let's go to our calculator. Go press 12 equal sign shift factorize, and you're gonna get 2 to the power of 3 times 3. Okay, then you go to 18. Okay, 18 equal sign shift factorize. 18 equal sign shift factorize. You're gonna get an answer of 2 times 3 squared. Okay, so this is another method. Okay, method 2, and I prefer to use this method because it's easy. Okay, method 2. This method is using prime factorization. So 12 and 18. So how to get the highest common factor now? Ukuthola highest common factor uthatha inumber kulama prime factors. Okay, this in this prime factorization, nayi prime factorization ka 12, nayi prime factorization ka 18, yabo. So uthatha number kulawo kulezo two, inumber nje yokuqala, which is the smallest power. Okay, if you check, you have 2 to the power of 3 here, you have 2 here, so 2 is the one that has the smallest power. Okay, why? Ngoba ipower ka 2 ubani? 1. Asibheke ngapha, iyiphi inamba ekhona ngapha nangapha? You know 3. You know 3 to the power of 1 here, you know 3 to the power of 2 here. So iyiphi inamba enepower encane? U3. You say multiplied by 3. Okay, multiplied by 3, and when you do that, you're gonna say 2 times 3 now is 6. So this is our highest, okay, prime, our highest common factor, I mean. So it's in method yokusolve le nto. Into yokuqala oyenzayo Lungile, you do ama prime factorization a numbers of 2, then you take a smallest power. Okay, number the small power ekhona ngapha nangapha, inumber ekhona kuphi? Ku-12 naku-18. Okay, u2 ukhona ngapha nangapha, but thatha lo highest one smallest power, thatha u2 to the power of 1. U3 ukhona ngapha nangapha, yes, nangu 3 nangu 3, but uthatha lo smallest power, then you multiply to the answer yakho. Then if you do that, you're gonna get what? Your highest common factor. Okay, let's move on. Let's carry on. Highest common factor of 18 and of 28 and 35. La benze ngenye indlela ngithi uyabona ukuthi bathola ama-factors, uyabona la ukuthi uma uthola ama-factors ka-28 u7 ukhona ngapha nangapha, and is the largest number a factor efanayo ngapha nangapha, which means it is highest common factor. Okay, but enye ukuyisolva engifuna uyijwayele because le yamathola ama-factors ithatha isikhathi eside, le ukuthi sithola ama-prime factorization. So go to your calculator, press 28 equals sign, shift, factorize, and you're gonna get that 28, it can be given to the prime of 2 to the power of 2 times 7. Okay, times 7, you see that. Then if you go to calculator again and go for 35, then you're gonna get that 35, let me see, 35 equals sign, shift, factorize, you're gonna get that it's gonna give you 5 times 7. Okay, so how to get the highest common factor? The highest factor, this thing goes very slow, sorry. So highest common factor, it's a method to get the highest common factor. You check in number first, or uthatha noma yiphi, uthatha ngapha nangapha, into yokuqala leyo Lungile, uthatha a number efanayo on both sides. If you check u2 akekho ngapha nangapha, so asunaki, u5 akekho ngapha nangapha, asunaki, but it's now 7 ngapha nangapha. Uma usubona inamba efanayo usino 7, okay, usino 7 ngapha nangapha, sithatha the smallest power. So into enzekile vese ayafana ama-powers, kuno power of 1 here, no power of 1 here. Okay, so the highest common factor sithatha the smallest power, so iyodwa, so 7. So that's how answer yakho highest common factor is 7. I hope that is clear. Okay, I hope that is clear. So let us move to the next part. Then let's check the following question. Okay, now if we check the following question, we have 3 numbers now. I want to see numbers with 3. Okay, nakhona it's easy to solve. We have 24. Okay, we have 24, we have 32, we have 40. Okay, so after we have these numbers, let's check now the prime factorization of 24. 24, if you punch in a calculator, we'll 2 to the power of 3 times 3. Okay, let's check it. 32 meso prime factorizer usinika u2 to the power of 5 pel. Okay, then let's check it. U40 maso factorize u40 usinika u2 to the power of 3 times 5 times 5. Okay, so that is that there. Okay, now it's in indlela yokuthola highest common factor. It's in indlela yokuthola highest common factor. We first need to angazi kwenzakala leli peni ngibhalisa into ebhedayo. Okay, now to get the highest common factor, this is what we're gonna do. Okay, so we're gonna say iziphi number eyifana yonke indawo. Sino 2 ngapha, sino 2, sino 2, which means u2 ofanayo. U3 uyafana yonke indawo, awukho la ku32, awukho la, so asunaki. Okay, so asithi kwi-highest common factor sibheka u2. Okay, ngoba ayikho enye inamba esibheka enye ngoba ayikho efana yonke indawo. Highest common factor sibheka inamba efana yonke indawo. Okay, yonke indawo. So if we check that, sesiyabona ukuthi okay, kahle kahle since ku2 ofana yonke indawo, sitheme siqeda ukuchecka lokho sibheka inamba ene smallest power. Lala kuno 2 to the power of 3, 2 to the power of 5, 2 to the power of 3. Yiphi inamba ene smallest power? Okay, should to 2 to the power of 3. Sithatha yona kuphela. Then u2 to the power of 3 uma upuncha calculator yakho, check 2 with exponent 3 kuphuma bani? U8. You get 8 as your answer. So 8 is your common factor. That's why even here you also 8. Okay, we got 8 even here. So that's why here we got 8. Okay, so I hope this is clear to you. Okay, now let's carry on to another one. Word problem. Okay, now it's a problem, a word problem. Find the largest square tile size to the tile of the floor of size 96 by 90 by 120. Okay, twathola ukuthi iyiphi largest square tile between the size of 96 no 120. So lena i-word problem, okusho ukuthi ayibhaliwe njengeyinamba kanje, akushiwanga straight ukuthi wathola highest common factor, but wena uma uyifunda i-problem ufuna ukuthi kahle bafuna ini i-highest common factor. Okay, so cela ukuthi ucheck-ke la between 96 no 120 ukuthi uba i-highest common factor. Yenza i-method right njengoba senza lana, check ukuthi uzothola i-answer yini. And highest common factor ka 45 no 60, checka nakhona uthole ukuthi uzothola ba. Okay, check the answer ukuthi njani. Okay, kanjalo. So try to do that. Okay, and now amanye questions, okay, that you can also try so that you understand better. Now my answer corner for 2.11 and 2.22. So in those common multiple as okay, so we only did the highest common factor here as shown in your scope. So that's all for this video. Cheers.